Last time we talked about what a probability distribution is. This time we're going to talk about, if you have a probability distribution, how you find the mean, the variance, and the standard deviation of that distribution. And we're going to talk about mathematical expectation or expected value of a random variable. First of all, the mean for a probability distribution refers to, let's say you have some probability experiment and you did it over and over and over again a whole bunch of times. And you kept track of all the different values you got for the random variable, all of those times you did the experiment. What would you expect the mean or the average of these values to be? For example, let's say you took a pair of dice and you rolled that pair of dice not just once, but many times. And each time you roll, you write down the total that comes up, and you take all those totals that you wrote down and you calculate the mean or the average. What do you think that average would be? I actually tried this. I didn't physically roll a pair of dice, but I got Excel to simulate rolling a pair of dice 1,000 times. So the numbers in this column here are supposed to represent 1,000 different dice rolls. First time I got an 8, next time it was a 3, then a 7, then another 7, then another 8, and so on. And I asked Excel for the mean or the average of all 100 of those dice rolls. And that turned out to be 7.015. If we try it again with a different set of 1,000 dice rolls, this time the mean comes out to be 6.96. If we do it again, this time the mean is 7.041, then 7.064, then 6.854, then 7.008. But always the average of those 1,000 dice rolls is either a little bit more than or just a little bit less than 7. And if I didn't do just 1,000 dice rolls, but maybe 5,000 or 10,000 or 1,000,000, I would expect the average to be still close to 7, even closer. So 7 is the theoretical mean for that probability distribution. That's what you would expect the average to be from a whole bunch of individual random dice rolls. Okay, so how is that calculated? To calculate the mean of a probability distribution, here's how you do it. For each value of the random variable, multiply that value by its probability. Then add all these together. So it's kind of like when we calculated a weighted mean by multiplying each number times the weight that goes with that number. But this time the probabilities are sort of acting as the weights. So here's the formula. It says mu equals the sum of x times p of x. So that's telling you in symbols what I just said in words. Take each value of the random variable times the probability of that value and add those all up together. So in our example where we had the number of red lights could be anywhere from 0 to 4. These are the probabilities. The mean number of red lights, we would calculate that by taking 0 times 0.05 plus 1 times 0.25 plus 2 times 0.36 plus 3 times 0.26 plus 4 times 0.08. And that comes out to be 2.07. So it's like the average or mean number of red lights you'd have to weight at is right around 2. It's 2.07. And notice this is like what we did when we calculated weighted means, where we took each number times the weight that goes with it and added those up together. And when we were doing weighted means, we would divide by what the weights add up to. So here, if we were doing that, we'd be dividing by what the probabilities add up to, but the probabilities in any probability distribution have to add up to 1. So the reason we're not dividing by something is we're really just dividing by 1. But any number divided by 1 is just that number. Now for the variance and then the standard deviation. For the variance, there's 2 different versions of the formula that we could use. They are mathematically equivalent, so they would give you the same answer as each other. And if you really wanted, we could show the messy algebraic details about how you could start with one and algebraically transform it into the other. But since they give the same result, we can use either one, and so I'm going to focus on the second version because I think that's easier to use. So what this second formula is telling us to do, what these symbols mean, is take each value of x, square it, that is, multiply it times itself, and then multiply by the probability that goes with that value. Then add all of those numbers together, and finally subtract the square of the mean. So it's each x squared times the probability of that x, all of those added together, and then subtract the mean squared. And for some reason, it's pretty common for people to forget that part. So don't forget that you have to, at the end, subtract the mean squared. Unless you've made a mistake somewhere, this should come out to be a positive number. If it comes out negative, you did something wrong. So what you get from doing that is the variance. And then if what you want is the standard deviation, you would take that number and take the square root. So in our red lights example, if we want to calculate the variance and the standard deviation, here's how we would do that. The variance would be 0 squared, which would still just be 0, because 0 times 0 is 0, times 0.05, plus 1 squared times 0.25, plus 2 squared, which would come out to be 4, times 0.36, plus 3 squared times 0.26, plus 4 squared times 0.08, minus 2.07 squared, because remember 2.07 was the mean, so we have to subtract that number squared. And that ends up being 1.0251. So that would be the variance. And then for the standard deviation, we would take the square root of 1.0251, and that comes out to be 1.01247 and so on. So about 1.01 for the standard deviation. Okay, let's try another example. What are the mean, the variance, and the standard deviation for this probability distribution? So I'm going to work this out, but if you think you know how this works and you want to try doing it yourself, pause the video and see if you can calculate those 3 things, and then unpause it and see what I get and make sure what you got matches what I got. And if it doesn't, figure out where you went wrong or ask me about it. So first of all, for the mean, we have to take 3 times 0.1 plus 5 times 0.2 plus 7 times 0.3 plus 9 times 0.25 plus 11 times 0.15, and that comes out to be 7.3. So the mean is 7.3. By the way, the mean should always be somewhere in the middle of these numbers. If you get a mean that's bigger than all of the x's or smaller than all of the x's, something's wrong somewhere. So the mean is 7.3. Now for the variance, we're going to do 3 squared times 0.1 plus 5 squared times 0.2 plus 7 squared times 0.3 plus 9 squared times 0.25 plus 11 squared times 0.15 minus, don't forget this part, minus 7.3 squared. And that comes out to be 5.71. So the variance is 5.71. And now the standard deviation would be the square root of that number, the square root of 5.71. And that is 2.38956 and so on, or about 2.4. So the mean is 7.3, the variance is 5.71, and the standard deviation is approximately 2.4. So one more thing we have to talk about in this section is expectation or expected value. So I'm going to end this video here and talk about that in part 2.